So welcome to part 44, Azure Data Engineering. So this is very important certification. For whom? If you are primarily into ETL work, extraction, transformation, loading, and you are not learning anything on Azure, anything on any cloud like Google Cloud, AWS, then you can just keep your job probably for one more year and that's it. So it is so important. So if you're not yet subscribed, do so. It will help you build concepts. See, we are not, if you're clearing certification just taking some paper and mugging the answers, you cannot do good work in projects. Okay. So your concepts are not great. We want to build great concepts. So with that intention, let us look at this question. You are designing an anomaly detection solution. You have your data. The data may have anomalies or may not. You want to detect it. For what data? Where is the data coming from? It is a streaming data. There may be an IoT device here. This is your IoT device. Okay. And the data is coming from here, from IoT hub. What is IoT hub? You know, bus stops. There are bus stops and then there are bus depots. IoT hub is a bus depot. That means it will collect data, billions of data from various IoT assets. You may have sensors throughout your building. For example, Infosys, I heard they have sensors. You enter a building, sensor will detect you have come. It will switch on the lights. When you exit it, it will switch off the lights. In bathrooms, Accenture, IBM, etc., they have sensors in the taps. Okay, the moment they detect, the water will come. Otherwise, the near will not come. So from such sensors, data goes to IoT hub. IoT hub is like your bus depot. All buses come there. From there, from IoT hub, you see this. These things can happen. Different things. You can pause and read this documentation. Okay, we know now data is coming via IoT hub, but it is saying, boss, please meet these requirements. Send the output to Synapse. What is Synapse? Synapse is a data warehouse in the Azure world. It is just like Snowflake. See, earlier people were using Synapse, AWS Redshift, and Snowflake told boss, I have created something for your platform, cloud platform, use it. Snowflake has a lot of advantages. So Snowflake is picking up in the market. So consider Synapse like Snowflakes. Now you have to identify spikes and dips in time series data. The data is a time series data. Why it is time series? Because the devices are continuously every 10 seconds, 5 seconds sending data. A lot of data is coming. Okay, so it is a time series data. So you want to identify okay when there are peaks and when there are crusts, and you want to minimize the development and configuration effort. Obviously, they don't want software engineers to earn money out of that project. So always they will say minimize cost, minimize development and configuration effort. They don't want to give any money to software engineers. What will you use? See, if you just scan the question, no, you come to know it is not a Databrick use case. Databrick is about big data, Databricks, big data. It is a open lakehouse architecture based platform. Okay, so you see this. I'm not making it up. Open lakehouse in Azure. Open lakehouse means just like open marriage. Anybody can connect. Your girlfriend is there, but anybody can talk to her boss. Don't worry. Similarly, you can talk to anybody. No obligation, no contract, nothing. That is Databricks for you. So Databricks will not work here because why it's not work? Can it not store high volume of data that is coming from Azure IoT Hub? It can store, boss. But when we are talking about minimizing development effort, identify spikes, time that there is a better solution in stream analytics. This is stream analytics. It is serverless, real time, and perfectly suited for this case. No code editor. Since it is no code editor, that means your development effort is reduced. That is how we are telling development effort is reduced. Okay, and since it is serverless, so your configuration effort is reduced. Who told you that you want to minimize development and configuration effort? The question only told you, no? You see this, minimize, minimize development and configuration effort. So this product is doing it for you. This product is serverless. That means no configuration effort. This product is no code editor. That means you don't have to do much of coding. So I would go for this product. Very good here. Why not Azure SQL database? The SQL database, no, you need to know SQL, boss. Okay. If you are poor in SQL, there is a development effort here. So you need to know SQL. It is good. It is managed. So the configuration effort will go down, but it will not be minimized to the level of stream analytics. First of all, streaming data, we don't put it here directly. You have to process it and so many things. Stream analytics is meant for that. It is born for that. Like Ferrari is born to race. Maruti Suzuki, have you heard that they participate in Formula One racing? Have you seen a Maruti Suzuki driver going in Formula One racing? Will he win? No, because Suzuki is born to save fuel. Okay, so this guy is born for a different purpose. Stream analytics is perfectly born for this exact use case. Okay, I hope you understood how did we decode this question and answer. Now let us move to the next question. See, in this question again, this is stream analytics, all real time question, real time data movement. Okay, so you have devices and your company is saying, boss, I will put more devices, get ready. If you don't like this world, let me give you a bad news, I'm going to put more devices. So now they're telling, boss, you need to monitor stream analytic job to ensure there is enough processing resources to handle the additional load. That means you're saying you should, I would keep increasing the load, you should be able to process it. So using which metric you will come to know, okay, the load is going up now, which metric you should use out of this, which metric, what is early input events? See, early input events whose application timestamp is earlier than their arrival timestamp by more than 5 minutes. That means uh, they did arrive immediately, right? Events whose application time, that means the time, there are two entities, A and B. A sent the data at 155, but B received it at 158. That is early input events. The early input events, it only tells you, boss, process some more data. Early input events means, see, early input events or late input event, it only says there is a difference in the timestamp. There's a difference. That's all. It does not mean that volume of data increased. It does not mean. So I will not use these two. Now let us look at watermark delay. See, in a lake there is a watermark, in a pond there is a watermark, in a river there is a watermark, in a dam there is a watermark. What does that mean? That means if the water rises above watermark, that means, boss, load is increasing, more water is coming. That means more rain has poured. That's why they say, oh, watermark, it is getting crossed. That means it is a situation of flood is coming soon. Here also, watermark is same concept. Watermark means it will tell you, boss, more data is coming now, you have to adjust for more data, flood is going to come, data flood is going to come. You can pause and read this if you want to understand more. In a very layman term, I'm telling you, it is just like a watermark in a river or in a dam. So does it tell you that more data is coming? Yes, it tells me clearly more water is coming, boss. There is more water coming. It clearly tells me that. What is input deserialization errors? See, there is a producer, there is a consumer in this real-time world. Kafka or some other things like Kinesis, producer, consumer. Deserialization error means error. There is an error. That means I am sending something to you, but there is some problem. Problem like what? I am giving you incorrect timestamp. Okay, I am making a mistake. I have missing parenthesis. These are errors. How can error tell you that more data is coming? Error is telling you that bad data is coming. Error does not tell you that more data is coming. It is telling you bad data is coming. So this would be wrong in our construct. Final answer, watermark delay. To remember clearly, remember it. Think of a dam. Think of a lake. There are watermarks. If water level crosses that, people say alert, alert, alert. Flood is about to come. Shit happens. Okay, guys, another question. You are designing a data warehouse, Synapse Analytics. Okay, yeah. So whenever you answer any question about Synapse, also correlate that with Snowflake and then try to check Snowflake documentation to see what is a similar feature available in Snowflake. Okay, so what are you doing here? What are you going to store? You are going to store website traffic analytics in a star schema. They are saying, boss, I have one fact table. This is my fact table. This table is 5 GB. This is the size 5 GB. They are asking you what distribution type and what index type will you use for this table. Now you immediately told, okay, let me think. But then they again come back and say, boss, one more requirement, please listen. You provide me fastest query performance. That means my read has to be fastest. I will not care of writes. I will care about reads only. This is my priority. This is my priority. So now what to do? So distribution. Now such question comes in different forms. Okay, concept is same. See, I want to distribute. I want to distribute. Why? To make my reads faster. So what will I use? I will not I will not use replicated, because replicated means uh, I would store in duplicate places. Okay, I would store in duplicate places. I have redundancy. I would not do that because that will make my writes very slow. Because every time I'll create multiple copies. Now round robin. Why is round robin used? Round robin. So if you have like three places, so it will store some data here, it will store some data here in the round robin fashion, so that equally, so it is democracy, everybody is equal. Okay, male and female are equal, uh, then all religions are equal. That is democracy. Okay, but beauty is here democracy will not work, so we will cut this out. Democracy is a myth. At some point your leader has to be autocratic to take the country's level from one place to the other. Okay, hash. Hash is something, hash is born to give you performance. Hash, what is hash? See, it takes one logic, that is deterministic hash function, and it distributes the data on the compute nodes. It distributes. So this makes read fast. Why it is fast? Because SQL Analytics has built-in knowledge of row locations. Built-in knowledge. That's why it is fast. Hash distribution works well for large fact tables. In our case, we have large fact table, 5 GB fact table. It works best. So this is my answer. Democracy does not work here. So democracy works where it works for people who are freeloaders. They want some benefits from government. They are freeloaders. They will produce a lot of kids. Okay, and they will create a liability on the government system. And usually they may be low IQ people. Usually, let us talk about index. What we are talking about indexes. Indexes again, non-clustered, clustered column store. What will work best? See, clustered column store will work best. See, this is created by default. You don't have to choose it particularly. Okay, it is created by default. Okay, why I'm referring this documentation? Because I'm not an intelligent guy, so I usually go to the source and show you the source, so that any doubt if you have that this answer is correct or not, this will not raise any doubt, no trust issues. Okay, so you pause this and read it. Clustered column tables offer both highest level of data compression and best overall query performance. This is what you want, right? You want high query performance, high query performance, high query performance. This is what we are getting. So this is our answer. See, clustered is working good if you are reading through dimensions, like you want to retrieve single row. But here, are you retrieving from dimension? No, you are retrieving from a fact table. Fact tables are big tables. Dimension tables are small tables. Give an example of dimension table, region. Give an example of fact table, sales. All sales transactions are stored there. And non-clustered would definitely not have an edge over clustered, because indexes, you have to be clustered. These will be our final answer. So please subscribe, understand the concepts, prepare for your cloud certification. The goal is not just certification. You also have to do good work in your projects. So if you want to do good work, then you should clear your concepts. This brings us to the end of part 44. See, one thing you should also remember about index is there is an index maintenance. You have to use these syntaxes: rebuild index equal, to continuously rebuild. Then only your performance will be good. Otherwise, your queries will not make use of indexes. Second is, what is the cause of poor column store index? If you identify tables with poor segment quality, you want to identify the root cause. These can be the causes: memory pressure when index was built, high volume of DML operations, or small load operations, too many partitions. So sometimes indexes are there, but it is not giving you results. So you have to go and check, is this one of these or multiple of these can be a problem. See you in the next part.